2. We have 4x squared plus 1 equals 4x. What would be my first move? Subtract the 4x. Good stuff. So we're looking at 4x squared minus 4x plus 1 equals 0. So we're doing this with the quadratic formula, and that's the key ingredient because, you know, completing the square and factoring are also options, and you're being told specifically to do it this way. All right, so we identify the a value, the b value, and the c value. So quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we have our a, b, and c values. We have a formula that contains a, b's, and c's, so we're in good shape. So negative b, I'm going to put parentheses everywhere I have to make a substitution. Probably need a bigger set of parentheses there. All right, so negative b, so negative 4, plus or minus the square root of negative 4 squared, minus 4 times 4 times 1, all over 2 times 4. All right, so we can clean it up. Order of operations is going to come into effect. So we're looking at 4 plus or minus. We have 16 minus 16, right? So I'm going to write it as the square root of 0 over, not 2, but 8. All right, now that's going to clean up further, but I'm just going to circle that 0 for a sec. I'll talk about that in just 1 minute. But we can clean this up further to say, because the plus or minus part is irrelevant, it zeroes out, so it's really just 4 over 8. So x equals 4 over 8, which simplifies to a clean 1/2. So we only get one solution here. All right. And it's kind of strange because most of the time we have 2 solutions, but if you really think about it, it's all dependent on whatever the radical is, right? Because that's the part that's getting plus or minus, right? So you're adding or subtracting whatever is contained within the radical. If it goes to 0, then there's nothing to add or subtract, and so you're pinned down at whatever the negative b over 2a is, right? So 1/2 is your only solution, your only root or 0 to this function, just more terms that mean the same thing, right? But I circled that 0 for a reason, because that's a determining factor. If you have a really nice number under the radical, then you'll get a really nice answer. If it's hideous, then you'll get a hideous answer. So your solution is solely based off of the quality of that type of number. That number is known as a discriminant. All right, so b squared minus 4ac is your discriminant. That's this guy. All right, it distinguishes one type of answer from another. All right. So if you can make a determination of what just the b squared minus 4ac part of the formula would give us, then you'll know what type of solution you're dealing with. In the early goings, that's really just going to end up being kind of more, if you're doing it for your own personal reasons, those reasons might include just a way of kind of seeing what you're up against. You know, you figure out b squared minus 4ac and you say, well, okay, that's a nice number, so this is going to be an easier problem to work with, right? But really, I mean, once you get that far, you might as well go the distance and figure out what the solutions are in and of themselves. The reality is you're figuring out the discriminant because you're being told to on the Regents exam, right? And because you're being told to on the Regents, I'm going to tell you to do it on quizzes and tests. Right? So as a standalone topic, it doesn't seem to have much value. But moving forward, it will have a lot more value because we're still living in the world of rational coefficients. So clean coefficients, normal numbers. But once you start throwing in other types of coefficients, so, imagine a function whose coefficients are other functions. So instead of 4x squared plus 1 equals 4x, imagine it's yx squared plus y equals yx. And you have to have a solution that involves that new variable, right? That's further down the line, but it's still something that you're working towards. All right, so there is additional meaning to this concept. It's just it doesn't seem overly meaningful right now. Now, depending on what kind of discriminant you get, you could have different types of solutions. So you could have a positive discriminant. You could have a positive discriminant in two ways, really. One in which it's a perfect square and one where it's not. All right. So number and type of roots. Well, if it's positive in a perfect square, what we're looking at are two real and rational roots. All right, so you'll get two real rational roots. So an example would be like 2 and negative 1/2. All right, so they're rational, meaning they don't include a funky radical. They're not imaginary, so you don't get a negative under a radical. They're numbers that you would expect to get through a factoring process. If it's not a perfect square, you get two real irrational roots. The third one we just did in the do now, you get 0. If you get a 0 under that radical, b squared minus 4ac is equal to 0, we got one answer, right? So what we'll get is one real rational root. Oh, and just, if this is not something that you're accustomed to, you may have heard this before. I may or may not have said it. I definitely didn't define it specifically, but I might have mentioned it in passing. The term root means the same thing as solution for a quadratic. So we've been finding roots all unit long. Anytime you find the solution to a quadratic when you set it equal to 0, you're finding the roots. All right, so don't get thrown off by that. If you get a negative, right, less than 0 is negative, you're talking about two imaginary roots. That's the same as saying non-real. That came up in some of the homeworks where you tried solving the problem, you got a negative under a radical, the hand went up immediately, what do? Say, no real roots. Done. Right? And in Algebra 2, you'll actually work with imaginary numbers, but that's a different story for a different course. Until they reinvent the curriculum again, at which point you'll learn all this stuff in like 3rd grade, and then like imaginary numbers you'll learn in like 4th grade, or like summer between 3rd and 4th grade, or something like that. They invent new ways to torture kids. So until that happens, it'll be Algebra 2 content. Anyway, problems, they're pretty straightforward. All you're asked to do is find the discriminant and determine what kind of roots you would get as a result. You're not asked to actually go the distance and find the roots themselves. Now, personally, what I did, because I didn't pay attention that day in class when I was your age, so I got to a point on the test where it's like, all right, describe the number and type of roots for each equation. They said use the discriminant. I was like, all right, I don't know what that is. So I just found the roots. I looked at them. I was like, all right, there's no radicals in there. So they're real and rational. You know, so the reality is you don't really need the discriminant to determine what kind of roots you're going to get. It just saves you a little bit of time and energy. All right, so if I'm looking for b squared minus 4ac, I still need to kind of treat it as a quadratic formula question. Identify the a, b, and c values. Compute. My screen is glitching. Is it glitching up there? No? Okay, because it's hopping all over the place over here. All right, so I'm just computing b squared minus 4ac. So negative 2 squared minus 4 times 10 times negative 9. So we're looking at 4 plus 360? So 364. All right, so what I need to do now, this is the thinking part. You go down the list, different possibilities. First off, I start with the fact that, well, this is definitely not 0 and it's definitely not a negative number. So it's a positive number. The choices, it's either a perfect square or it's not. How do we know it's a perfect square? Well, you type it in your calculator and it's either a perfect square or it's not. So is 364 a perfect square? No. All right, so what we would say, I just make a little note here. We're saying b squared minus 4ac is greater than 0, positive, and not a perfect square, a PS for perfect square. Therefore, 3 dots in the form of a triangle means therefore. You write out the word. You don't even have to write therefore. So then, whatever, just some sort of transitional term. What we're looking at is, and we draw the conclusion, 2, try that again, 2 real, irrational roots. So we found a discriminant. Now it said use the value of the discriminant to determine. It didn't actually, I mean, it's implied, I suppose, but it didn't explicitly state find the discriminant. It didn't tell us to tell the grader to indicate what the discriminant is. So technically, I only need from the red stuff down. If I write this and everything that follows it, I've answered the question. I did use the discriminant, I just didn't bother telling them what it was. All right, so that's a way to kind of, I don't know if I should say this. I'll say it. It's a way to fake your work if you're not really sure. Like, you know the discriminant formula, you're not really sure how to use it. You're kind of taking a shot in the dark on the final answer. So I don't know if it's greater than 0, less than 0, equal to 0, whatever, if it's a perfect square or not. So you just write it and just hope for the best. And it's a way to get some partial credit, but obviously doing the work is a way to get all of the credit. So numbers 2, 3, and 4, they require you to manipulate it a little bit, like the do now problem. So first step in number 2 would be to get everything onto the same side. So x squared plus 6x minus 8 equals 0. So understood coefficient of 1 for the x squared. It's plus 8? Meh. Thank you. So a, b, and c. B squared minus 4ac. So 6 squared minus 4 times 1 times 8. So 6 squared minus, well, 6 squared, so 36 minus 32, right? So 4. All right, so b squared minus 4ac is greater than 0 and is a perfect square. Therefore, we're looking at two real rational roots. This is what time you normally wake up when you don't have school. It's not bad. So 8x squared minus 8x plus 47 equals 0. A, B, C. So again, b squared minus 4ac. So negative 8 squared minus, bless you, minus 4 times negative 8 times 47. Right, now just bear in mind, I don't care about the number itself as much as I care about what kind of number it is. Okay, so we start off with positive or negative. Positive, negative, or 0. And then after that, perfect square, not a perfect square. Oftentimes we have to figure out what that number is. But let me just ask you, just based on what you're looking at here, is this going to be a positive number or a negative number? It's going to be a negative number. All right, because we're taking 64. Oh wait, sorry. It's going to be positive. I misspoke. What? So we're taking a positive number and we're adding something to it that's really positive. All right, so two negatives will give us something positive. When you square something, it's positive. All right, so it gives you a sense right off the bat of what you're looking for. So you can eliminate some possibilities, thinking in terms of multiple choice. You eliminate some possibilities right off the bat. All right, although I put a negative 8 in there for some reason.
That's why.
Yeah, so based on what's written here, positive, but what it ought to have been is negative. So everybody was right except for me. Right. So anyway, positive minus something really huge, right? So we know we're definitely looking at something that's negative. So b squared minus 4ac is going to be less than 0. I don't care what the number is. Once I know it's negative, we're looking at two imaginary roots. All right. Now the last one, so covered 3 out of the 4 possibilities, so you can probably just mail it in and assume the last one will be the 4th one. But let's go through the motions anyway. You could move the negative 5x squared to the other side and clean it up, or you can move everything to the right-hand side. It's up to you. It's not going to make a difference. For convenience, I think it makes sense to move the 5x squared over. So b squared minus 4ac. So negative 10 squared minus 4 times, I'd like to think I can't screw this one up. It's a and c are both the same numbers. So, 100 minus 100, so 0. All right, so b squared minus 4ac is equal to 0, which tells us that we're dealing with two real rational roots. One real rational root. All right, so what we get from this is a technique. you know, it tells us the nature of the roots. But what I like it for is a way of verifying that I'm on the right track because, and really, aside from this one thing at this point, you might look at this and say completely useless topic, and I would agree with you. These two situations, tell us that what we're working with, our original quadratic, is factorable. Right? So why would that be important? Well, if you're dealing with a free response problem and you just sat there and you have to solve it by factoring. The question, it very clearly says solve by factoring. And you just spent the last 5 minutes trying to find the factors. You've tried every possible combination, and now you're starting to question, all right, did I screw this up? Or is it a bad question or something like that? By finding the discriminant, you can verify to yourself, first off, that it is factorable, and then also what you're looking for. Because if my discriminant is equal to 0, I'm looking for two identical numbers, right? Because what it means is that you're dealing with a double root. If you get one real rational root, that means that the quadratic factored to two identical factors. So it was something like x minus 2 times x minus 2. And then when you solve each of those, you get the same answer, so you only write it once. All right, that's a good one because it tells me, all right, I'm not looking for two unique things. I'm only looking for one thing that's going to work twice. This one tells me that I'm looking for two unique factors that would satisfy the equation. All right. Also, in the next unit, we're gonna talk about the graphs of quadratics and how you can snag a factor from the graphs. And in fact, let me show you really quickly on the calculator, just because it's a good.
Ooh.
It's screaming. Yeah, like 5 days away from it, and now it's like yelling in your ears. Let me take. Yeah, let me take this one right here. X squared minus 6x plus 8. Oh, wrong one. X squared minus 6x, was it minus 8? Oh, plus 6x plus 8. So I'm just going to hit zoom 6 and look at the picture. It's a standard zoom. It brings a negative 10 to 10 frame. Vocabulary is pretty useful in this context because if I'm talking about that term root, which also is synonymous with solution for a quadratic, is also synonymous with x-intercept. So points where it crosses the x-axis. Sometimes you could just take a look at the picture and see where it crosses the x-axis and have a sense of your answer. All right. So here, I put in x squared plus 6x plus 8. Just by counting tick marks, I can see, or at least it appears, that it's crossing an x equals negative 2 and x equals negative 4. All right. So if we play that out, and I'll just do it off on the side, or maybe on the bottom here. So here's the graph. Here's my roots, something like that. This one is x equals negative 2. Oh, sorry, negative 4. And that one is x equals negative 2. If I needed to factor my trinomial, I had x squared plus 6x plus 8. I can kind of work backwards, because if I know that the result of my t-chart was going to be x equals negative 4 and x equals negative 2, I could figure out the factors that went along with that, right? Just by adding the 4 to both sides, I would get x plus 4 equals 0 and x plus 2 equals 0. In which case, I'd be looking at x plus 4 times x plus 2 equals 0. All right, so I'm working completely backwards in an attempt to verify that the roots that I got from the graph correspond to this equation. And if they do, then I'll have the factors. Right? And if the question's only asking me for the factors that correspond with a particular function, then I'll have them just by knowing what the roots are. All right, so little shortcut, it's kind of nice. If you know what x is equal to, just flip the sign and put it in a binomial and you're good. All right, so I can look at really a bunch of possibilities. So let's say I have x squared minus 9. Pretty simple one to factor if you needed to. But let's say you didn't know the factors. I see that I have roots of x equals negative 3 and x equals positive 3. So x plus 3, x minus 3. Right? Just reverse the signs and put them in as factors. Right? So between completing the square quadratic form and just pulling information from a graph, what we're looking at are ways to get around the concept of factoring. Right? There's more to it than that, but at this level, that's really the only thing we needed for it. All right. Like I said, Algebra 2 calculus, I talk about that all the time. You'll get to a point where you expand upon this stuff in more meaningful ways, but for now, they're just different strategies to really accomplish the same thing. All right. So that's that. And that's actually the unit. So everything else from here on out, so between tomorrow and Friday, is really just you preparing for the test. All right, so just continue to work in your packet with the goal being to try to complete the packet before the test.